Today we will review 6th grade math lesson 6.2. This lesson will cover using rate reasoning to convert within measurement systems. Here is your I can statement. I can write and use equivalent fractions or conversion factors to convert units within a measurement system, and I can explain my solution methods to others. A conversion factor here is a ratio which represents the relationship between two different units. A conversion factor is always equal to 1. For example, in the ratio 1 minute over 60 seconds, if you replace 1 minute with its equivalent 60 seconds, it becomes clear that 60 seconds over 60 seconds equals 1. When using conversion factors, it's important to keep track of the units. Without the units, the ratios are not conversion factors. To use conversion factors, the units you currently should have should be on the bottom of the conversion factor, and the units you want to have should be on the top. Sometimes you must use more than one to arrive at the units you want. So this right here is the most important thing you need for today's lesson and tomorrow's. So make sure you write this down here. If you're keeping a log of all your vocabulary, this is a very key formula and a way to do conversions. That you'll want to do the ratio of the units you want over the units you have. And I will show you examples of that as we solve these problems. If you want to go ahead and look at in your practice book, in your student book, the homework is on page 191. There are more examples like these. There is also a table of measurements that you should reference. And that's on page 186 in your book, and you'll need that to do the homework problems and even these problems. That will help you. I also recommend that you use a calculator for today's lesson so that you can practice how to do conversion factors. And most of these problems are dealing with large numbers. So I encourage you to pause this video and complete these problems on your own first, and then check your answers. So here we go. How many hours are there in 2 years? So hours is your want, the units I want to have, and 2 years is the units I have. Step 1, determine the conversion factor you will need to convert from years to hours. So if you look at that table of measurements in your book on page 186, it gives you these factors. That we have 365 days in 1 year and we have 24 hours in a day. For this example, we are going to need more than one conversion factor to arrive at hours. The next thing you do is you multiply to converse, and you cross out the units as you solve the problem. So if we go back and read our problem, it says that they're asking us in 2 years, so that's where we get that. Okay, how many hours are there in 2 years? So we start out our problem with 2 years. When they're writing these conversion factors, remember they are doing units you want over units you have. Then they take 365 days over 1 year times 24 hours over 1 day. We cross out the years here, and then we cross out the day. So then the next step here is that they don't have, as I would rewrite your problem before you go on. So what's left? 2 times 365 times 24 hours. And if you multiply that, then you get 17,520 hours. So there are 17,520 hours in 2 years. Let's work on the next one together now. Giuseppe is 74 inches tall and Raymond is 6 feet 1 inch tall. Who is taller? So we, in this problem, are comparing inches and feet. So you can see Giuseppe is 74 inches tall and Raymond is 6 feet 1 inches tall. So I want to convert this to inches. So I have the units I want over the units I have. And I know the units I want is going to be in inches. And the units I have is going to be in feet. And then I look at my table of measurements and I see that 1 foot is equal to 12 inches. So now I want to say, okay, for Raymond, I have 6 feet times 12 inches over 1 foot. So I'm going to now cross out feet. And what I have left is 6 times 12 inches, which is 72 inches. And then I need to add the inch here, 1 inch. So he is 73 inches. So now let's look back at our question and ask, what are they asking me? They're asking who is taller and to explain. So I know that Giuseppe is 74 inches because that's what they told me in the problem. And then I just figured out that Raymond is 73 inches tall. Now they're wanting me to explain my answer. So I would say 74 is greater than 73. So Giuseppe is taller. All right, let's go on to the next question. A water cooler can hold 5 gallons of water. How many quarts of water does the water cooler hold? So we have 5 gallons of water. This is what I have. But they said how many quarts of water? That's what I want. So let's do our problem here below. So I have want over what I have. So what I want is quarts. Abbreviation for that is QT over gallons. And I know there is 4 quarts to 1 gallon by looking again on that table of measurements on page 186. And then I know that I need to multiply that by 5 gallons. Then I go ahead and cross out the unit of measurement. So what I have left is 4 quarts times 5, so that's 20 quarts. For the last problem, it says for each problem, convert one of the measurements to the indicated units and compare the 2 measurements with a greater than, equal to, or less than sign. So the indicated measurement here is given at the end of the problem. So the first one, the indicated one, it means I need to convert everything to meters. So if I have want over have, So I know that I want meters. Okay, so I want meters because this is what I want. But I have kilometers. So look on the conversion chart, and it says for 1 kilometer you have 1,000 meters. So if I multiply that by 2.9 kilometers, then I can cross out the kilometers, and I would have 2.9 times 1,000 meters, which equals 2,900 meters. So now I need to write an inequality. So if I have 3,000 meters is greater than 2,900 meters. Okay, let's do the next one. Again, we have to use our conversion of want over have. And I want grams, and I have kilograms. So I know that there's 1,000 grams in 1 kilogram. And then I multiply that here by 1.7 kilograms. So then I cross out the kilograms. Then I have 1,000 grams times 1.7, which is 1,700 grams. So let's write an inequality for our answer. I know that 1,700 grams is less than 1,800 grams. So that is our lesson for Module 6, Lesson 2, Grade 6.